Right folks, the next question that we're given on the surface geometry topic is another development question, and it's another transition piece. So we can see we've got the 3D graphic here of a feeder, a fertilizer feeder or a fertilizer spreader, and we can see that what we're doing is the top of it here, the funnel shaped part. So we can see we're given the elevation here and the plan here, but we'll just read the question to start off. So it says the projections of a hopper from a fertilizer spreader are given. Complete a 1p surface development of the solid. So like a previous question that we've previously done, we're going to use the triangulation method, where we split this plan up into various triangles, and we're going to obtain the various true lengths that we need from them. So starting off any one of these questions, what we're actually going to do is first of all just identify some true length straight away. So we can see the top of the hopper feeder. It's a straight line up here in elevation. It's parallel with the XY line. This line up here, so that means these lines here, these four lines, are all true lengths. So if I was to label them, and I'm going to use letters for them, I'm going to use A, B, C and D. So if I label them up here, A is at the front as I look at it, so A is there, D is inside here, and B is at the front, B and C. Okay. Now, what I also have to recognize, so I've got those four true lengths, A to B, which is the same as C to D, D to A is the same as C to B. Now, at the bottom of it, we can see that it is circular shape, so it's rectangular going into circular at the bottom. And anytime we have a circle and we have to develop it out, we are going to split it up into 30, 60. Straight away, we're going to do that first. Okay, now that that has been split up into 30, 60, we're also going to use labels. So I'm going to start my 1 here, to 2, 3, 4, and so on. Okay, and if we label it in plan, once again, also label it in elevation. So, we can see 1 is up there, 7 is on the outside. Okay, now what I'm actually going to do is I'm going to try and recognizing the plane surfaces that are actually on it to start off with. Okay, so because there are some various plane surfaces on it, I'm just going to recognize them to start off with. So we have A to 1, D to 1, A to 4, 4 to B, B to 7, 7 to C, 7 to 10, or C to 10 I should say, and 10 to D. Just join that one up there fully. And there we go. Now, all those lines are actually, we can see various ones. So A to 1 we can see is actually already here. So if I was just to label it, so we got 1 on the outside, and at the front we have 2, 3, 4, 5, 6, 7, 8 is at the back, 9, 10, 11, 12. So if I was to put in those lines in my elevation, well, A to 1 is already done, which is the same as D to 1, B to 7, C to 7. But C to 10, D to 10, B to 4 and A to 4 are all here. So just put that in. There we go. So done in elevation, also do it, or sorry, done in plan, also always put it in elevation. Now what we have to do is, we can see, if you just break up, we can see these triangles here. So we've got this triangle here, this one, and this one. We can see that this one and this one are the same, and this one and this one are the same. What we have to do is recognize that they are plane surfaces. They don't really actually have a curve to them. It's these bits inside and here, in there, in this section here, this section here, here, and here that are actually the curved bits. So all of them we're going to use the triangulation method. So from every corner, so A is going to join to 2 and 3. B is going to join to 5. 6 is also going to join to B. C is going to join to 8. And the same with 9. And so on. And once again, if we do it in plan, we should also do it in elevation. And a lot of these lines that I'm actually drawing now are actually front and back, so they're in 2 places. Because that's for the 3 and 11 to 8. And D, this is the 2 and 12. There we go. Okay, so now that is basically the whole thing broken up, and what we're going to do is we're basically going to be drawing every one of these various triangles. So we can see we got DA1, we've got A12, A23, A34, and every one of them we're going to do them one by one by one, and we're going to get the true shape of all of them to be able to create the surface development. But before we do that, we have to basically get the true lengths. So as I said, starting off, we've got the true lengths of the rectangle. A to B is the same as C to D, D to A, and C to B are the same as well. So obviously, if we look down in a plan view, because this circle is on the bottom, we cannot measure the circumference of a circle, so we just take the true length from 1 to 2, which is the same the whole way around, 2 to 3, 3 to 4, 4 to 5, and so on. But what we need to get is the true lengths of these lines in here, and it's recognizing which ones are the same. So let's just start with this corner here, A1, A2, A3, A4, and I'm just going to explain a little bit about getting the true lengths of them. Okay, first of all, recognizing A to 1 is the same as 1 to D. A to 1 and 1 to D are the exact same, and they are also the same as B to 7 and C to 7. So it's very important to recognize that. So with that kind of knowledge, also we could actually recognize that A to 4 is the same as 4 to B, which is the same as 10 to D and 10 to C. So straight away there, once we've worked out those two true lengths, we can straight away off the bat just know that we have them worked out. Once we have A to 1 done, we actually have it got for 3 more. Once we've A to 4 done, we've also got it done for 1, 2, 3 more. Okay? Now, it's a case then of recognizing what is A to 2 the same as. A to 2 will be the same as 12 to D, 8 to C, and just recognize, look, 2 followed across is the same as 6 to B. So once I've worked out A to 2 is the same as 12 to D, 8 to C, and 6 to B. And then A to 3 will be the same as 11 to D, 5 to B, and just work it out, yeah, 9 to C. So what I have to do is I have to work out 4 true lengths of these guys in here that will give me the actual true lengths of all 12 lines. Because you can see we have 12 lines. 1, 2, 3, 4, 5, 6, 7, 8, 16, 9, 10, 11, 12, 13, 14, 15, 16. Math's a little bit wrong there. Okay, so we're going to use the cone method here to be able to work that out. So if I take A as the apex of a cone, and I want to get the true length from A to 1. Okay, so if A was the apex of a cone, which is up here, okay, that was the apex of a cone, and we can see we've got a cone shape there. Now that's not the true length from A to 1 there, because A to 1 in plan is not parallel with the XY line. Really, we'd have to bring it down here. But what we do know about a cone in plan, when we look down on top of it, if A was the apex, that is where the center is. And if 1 was on the ground, that would be my radius. From A to 1 would be my radius. So I'm actually just going to take that distance there, from my A to 1, okay, and I'm going to come up here, and I'm going to mark it out. Okay, now, at that point where I marked it out, I'm actually going to extend out my XY line. Okay, extended out my XY line there, and now that was my 1, right there. Very important, make it a little bit bigger. Now, that was my A to 1. There we go. That's my true length from A to 1. Now, another true length I could work off of A. I'm going to work off the kind of the triangular shapes here. So A1D. Now I'm going to go to A4. Okay, because they seem to be the two longest ones. Now I've got 4. So the same thing. I take the radius. And if we imagine the radius, all we're going to do is from the apex, because underneath the apex when we see it in plan we draw a circle. And what I have found there in that exact position is 4. So that's my A4 true length. Okay. That is my A to 4 true length. Now, with that in mind, straight away, off A to 1, which was this one here, A to 1, A to 1 was the same as 1 to D, which was the same as 7 to C and 7 to B. So there we go. Just have to know that, okay? Now what I'm actually going to do is, in the space up here, I'm going to create another one, rather than getting mixed up here, because I'm going to actually have these 2 and 3 would fit inside in here somewhere. So rather than getting just a bit messed up, I'm going to create another cone. Okay? And it will have the same height as A previously. So I'll just drag A across. And that's another A, just so you know. Just creating more true lengths, that's all. There's A again. Now, once again, I got to get the true length from A to 2 and A to 3. So A to 2, take that as my radius, which would be the same as D to 12. And from where A is, mark it off there. And once again, this was my, just remember, 2. So that's my true length. So I've drawn in from A to 2. Okay, and now the very, very last one, which is A to 3, which would be slightly bigger, I'd imagine, than the 2. Yep. There we go. And same thing from here. Mark it out. And that is my 3. Okay. That is my true length. The reason we need all these true lengths is because essentially what we're drawing is all these triangles, and we're drawing them all as true shapes. So up there right now I have worked out 1, 2, 3, 4, and every one of them has another 3 with it, so that makes altogether it's 16. I've actually got 16 true lengths there. It's just recognizing, and rather than writing it in for every one of them, I'm just going to recognize A to 1 is the same as D to 1, C to 7, B to 7. A to 4 is the same as B to 4, C to 10, D to 10, and working on in that sequence. Okay, so at this point we've actually worked out all our true lengths, so we're actually just going to start the question. So I'm going to start in position D here. I'm going to pick a point I had picked previously. So right there is my position D. And I'm going to start off by drawing D1A, this triangle right here. Okay, now, so I'm just going to take that as a true length straight off the sheet. Somewhere down there is going to be my A, so I take this as a true length from D to A, and there is my A. And now what I need is the true length of the line from D to 1 and 1 to A, or A to 1, which are the exact same. And just recognize which one is it up here. It's actually the first one that I got, which is this guy. So take him, and from D, little arc, straight away label it, that is point 1. Join it up. There we go. That is the very first one. This section here, tick him off. Okay, now what we want to do is we want to find 1 to 2, 2 to 3, 3 to 4, and as we're finding them this way, we will also find 1 to 12, 12 to 11, 11 to 10. Okay, so what I'm going to do is 1 to 2 is the same as the distance from 1 to 12. So I'm going to take that straight off the sheet. That distance right there. Somewhere along that arc is going to be number 2. And somewhere along the arc going this way is going to be number 12. So now I need the true lengths from A to 2 and D to 12. And they are going to be the exact same. So it's just a case of recognizing A to 2. Which one was it? Oh, I can see it here. So it was this guy here. Because that's where the 2 is. So take that as a true length. So that'll be the same as A to 2. Which should be the same as D to 12. Okay. So once again, label your points. There's 2. There's 12. Now, what I need to find is from 2 to 3. I'm just going to keep working in this sequence then. So 2 to 3, which would be the same as 12 to 11. So at 2, make an arc. Somewhere along there is 3. And at 12, make an arc. Somewhere along there is 11. Now I need the true length from A to 3, which is the same as D to 11. So wherever my 3 was, up to A to 3, and D to 11. Once again, very important, label. Okay, the exact same thing again. Now I have to get the true length from 3 to 4 first. And 3 to 4 will be the same as 11 to 10. So for 11, somewhere along there is going to be 10. It's probably going to be a little bit, or I'm not exactly sure. And the exact same here. Somewhere along there is going to be 4. So now I have to get the true length from A to 4, which is the same as D to 10. So on to the fourth one. A to 4. So there we go. And D to 10. And straight away mark it off. There's 10 and there is 4. Now that I've found the various points, I'm going to join a couple of them up back to their respective letters. So 4, 3, 2, and the exact same here. 12, 11, 10, and as I have done them, I will also tick them off here. So done, 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 done. Okay, straight away now, going to get this triangle, and then I'm going to get this triangle. Okay, because I'll fit that triangle up here and down here. So take the true length from A to B, which is there. So at A, somewhere down along here is going to be B, and that'll be the same as D to C. So somewhere up here is D to C. Now I'll just squeeze it up a little bit further so you can see it there. Okay. Now somewhere, as I said, up here is going to be C, and somewhere down along this arc is going to be B. So to recognize that, we have 4 got already, and we have 10 got already, because we can see 10 was here and 4 was here. So I need the true length from 4 to B and 10 to C, which is the exact same. So 4 to B is the same. 4 to B, just recognize that, look, 4 to B is the same as 4 to A, so we can see it here. So there we go. We take that true length, and from from 4, as you can see, I have to extend my arc down here a little bit further, but before I do that, I will do it from 10. There we go, because it was the exact same for 10. And just come back here and extend this arc down further. You can never be 100% sure where they're going to cross. So at this point now we have point B, and at this point we had point C. So once again, join them up, and they are the biggest triangles on the structure, on the surface I should say. So there we go, and once again, tick, tick, that much done. Now at this point what I will do is, as we know in here, they're not straight lines, it's actually curved, so I will just put that in as best I can and as neat I can. There we go. Okay, now at this point what I'm going to actually do is, I'm at B here, I'm going to do the B to 5, B to 6, B to 7 section, and I will fit in a little bit more up here. I'll actually fit in the 10 to 9, 9 to 8, 8 to 7, and 7 back to C up here. Okay, because while I'm doing one side I might as well do the other. So now 4 to 5, so take that as a true length, which would be the same as 10 to 9, so mark off 10 to 9, so somewhere along there is 9, and somewhere in here is 5. Now I need the true length from B to 5, and it's just a case of working out. Look, so if we follow it here, I need the true length from B to 5, and if we follow it over here, that was the same as A to 3, so I know I'm going to my 3 one up here at the top. There we go. So from B, mark it there, and same from C. It becomes quite repetitive, and it's just a case of getting into the rhythm. So we're on 5 here, and at this one, 12, and this will be 9. Yep. So we go again. So we've done 5, now we're on 5 to 6, which would be the same as 9 to 8. So somewhere along 9, mark off there is 8, and 5 to 6. And now I have to get the true length from B to 6, which would be the same as C to 8. So B to 6, and follow it over because we did it all off of A. B to 6, which is the same as A to, follow it over, yeah, A to 2. So we go, there we go. There will be 6, and from C will be 8. And now we have to find 7, and they're both joining up to 7. So 6 to 7, and 8 to 7. And the exact same thing, we need the true length now from B to 7 and C to 7, which are the exact same, which are the same as A to 1. So we go off to 1. True length up here. So B to 1, which is there, and C to 1, which is there. Or sorry, C to 7 I should say. And this was 7 as well. There we go. And once again, join them all up. Take them off, make sure I know I'm going correct. So there's them ones, and the exact same up here. Okay, once again, fill in the curve. There we go. Shows there now. Okay, and at this point now we can see that if I just take them off, because I've done this guy, this guy, this guy, this guy, this guy, and this guy, I just have this last triangle here, BC7. And we can see we've already got C7 here on this side. I can't really fit it in over here, I have no room, so I'm going to do it down here. So I'm going to finish on C7, so I need to find C over here. Okay, so take the true length from B to C, that distance there, have B, so somewhere out along that arc is going to be my C, and now I need the true length from 7 to C, and 7 to C was the same as 8 to 1. Let's take that from where I originally got it at the start, and at point 7, where it crosses, that is my C. Join that up. And there we go. Last one done. Now, just going to speed it up and I'm going to heavy it in. Okay, that's the question complete there, guys. That is the surface development of the transition piece here, of the elevation and the plan of the fertilizer spreader. As you can see, it wasn't exactly a square this time, it was a rectangular on top. So we can see obviously the various different sizes of the big triangles we have inside in here. Once again, we do not put in any of the triangulation lines in hatched because they are not fold lines of the piece. They are just there to help us understand it and locate our points. Once again, guys, hope you found that helpful, and understanding up here, especially if I just zoom out there a little bit so you can see it properly. Up here, and understanding the true lengths and how we got them is very, very important, and recognizing that I didn't have to work out the 16 true lengths, just recognizing that A1 was similar to 1D, C7 and B7 here, and understanding that once I had 1 I actually had 4. And it would actually help me just going a long way. It's just a case then of when I'm actually completing it down here, it's very, very important that you just take your time and you work through it in a slow, methodical process. Okay, hope you found that helpful, guys. Question done.